so he zapped on over to find me.
Inquiry time, Sarah. Inquiry time. There's something I must find out.
Talk to you later. Someone's turned up with a sore head by the look of it. Good morning, XP.
Oh, good morning, Sarah. Oh, I'm sorry, Sarah. I've had a dreadful morning.
Yes, I thought something was up. So, what is it you want to find out?
Can you turn your ears off?
What?
Turn them off, like you do the sound on the television. Turn it off, so you just see the pictures.
I don't think ears work like that somehow, XP.
Well, how do they work? Let me have a look at yours, Sarah. No, I can't see from here. You're going to have to take the top of your head off. Does it have a lid?
No, it doesn't. Look, why don't you just sit down and explain to me what you're talking about?
Oh, okay, Sarah. The thing is, I keep getting woken up by all these different sounds.
Well, then we'll look up sound.
Oh.
Okay. Right. S-O-U-N-D. Choose. What is sound? Fascinating facts. Noise pollution. Which one shall we have?
Well, let's start at the beginning.
Oh, okay. What is sound?
Sounds are created when things vibrate. Some things vibrate when they are hit. Others vibrate when they move. The buzzing of a bee is really the sound of its wings vibrating. Fast vibrations make high sounds. Slow vibrations make low sounds. If we slow the bee down to make its wings beat slower, the sound gets lower. If we speed the bee up to make its wings beat faster, the sounds get higher.
Hey, I never knew I knew that.
What?
Well, that stuff about slow vibrations making a low sound and fast vibrations making a high one.
I don't understand.
I'm not sure I do either, but I know it's true. Look.
Well, that's good. It's a start. But I need to know how sounds get loud.
Well, let's see what we can find in here. Okay, shall we see fascinating facts?
Yeah.
You got it.
This is a howler monkey. You can hear its roar up to 18 kilometers away. That's as far as the length of 200 football pitches. The sound a grasshopper makes is actually the sound of it rubbing its legs together. In olden times, church bells were sometimes rung to warn that enemies were coming.
I found out a good place to start my inquiry. I'm going to have a day out and go and ring some bells. Do you want to come?
Not today. I've got swimming practice.
Oh.
So you're on your own.
Okay, well, I'll just go and pick a pack, Nick. Pick a nick-pick. Nick-a-pick-pack. Oh, I'll just go make some sandwiches. Disconnecting. Express minus 3, 2, 1.
So, off he went on his inquiry. I had a little while before it was time to go swimming, and he'd given me an idea for an inquiry of my own. I wanted to see if I could help him with his noise problem. I thought I'd find out about ears. After all, I own 2 of them. Meanwhile, XP went to London. He found out about a bell expert who lived there, and he thought he'd make a day out of it at the same time.
Express minus 3, 2, 1.
He got a bit lost at first, because he's not too good at reading maps. That's why he's on Earth in the first place. He was supposed to be going on holiday to Alpha Centauri.
Express minus 3, 2, 1.
Still, he found the right place eventually.
Express minus 3, 2, 1. Scan to identify. Audio on.
Activated. Scanning. You are outside a university science laboratory. This is Michael. He is an audio scientist.
Hello, I'm XP. I need to know more about bells because they're so loud.
You've come to the right place. I know about bells. We have some handbells over here.
Oh, what makes that noise?
The bell has a clapper, and when the clapper hits the side of the bell, it makes it vibrate. That makes the noise.
Activate smart specs. Scan to confirm.
Confirming. The clapper makes the bell vibrate. The vibrations are the sound of the bell that you hear.
We can see it better if we look at this little cork ball. If I bring the bell up to the ball and the bell is not vibrating, then the cork ball hardly moves at all.
Activate smart specs. Scan to confirm.
Confirming. The bell is silent. There are no vibrations. The ball does not move.
If, however, I make the bell vibrate, you can see it bounces off quite violently.
Scan to confirm.
Now the bell is making a noise. It is vibrating. You can see the vibrations making the ball jump. Michael is not pushing the ball with the bell. The ball is moving because of the vibrations.
Would you like to try a little one? That's the littlest one we have. Here's the biggest one. Much deeper note and a louder sound.
So the bigger the bell, the louder the sound.
That's right, and the lower the note.
Have you got a really big bell?
Not here, but I know some people who have. Perhaps you ought to go and see them.
So Michael took XP to St. James's Church, Bermondsey. There was a bell ringing practice going on, so all his friends were there.
Activate scan do and record. Michael, do these big bells work in the same way as the small bells?
Yes, they have a clapper just like the small bells, and when the clapper strikes the side of the bell vibrates and we hear the sound.
How do the sounds get to my ears?
That's a slightly tricky question. To answer that, we'd best go outside.
All right, I'll go first this time.
Michael took XP to a nearby pond and showed him what happened when he dropped a stone into the water.
If I throw the stone into the pond, it makes the water vibrate, and the ripples spread out from where the stone landed, just the way that the sound waves spread out from the bell when we rang that.
So sound vibrations spread out like those ripples?
That's right, in a circle.
Michael, would you help me do a test?
I'd love to.
Do you think you can keep the bell ringer sort of ringing away?
It'd be a pleasure.
Great. Thanks a lot, Michael. Bye. Activate smart specs. Audio on. Access Scandu by remote.
Accessed.
Access ripple pattern.
Accessed.
Plot flight path for matching sound scan.
Flight path completed.
Scanning to record. Express -3, 2, 1.
XP asked Michael to keep the bells ringing while he did a super fast sound scan. He drew ripples round the church on a map and then set off to measure how loud the sound was at different points all around. He wanted to see what the results would tell him.
Scan complete. Display results.
Displaying.
Show distance.
This is the distance.
Show loudness.
This is the loudness.
I think I get it. The further sound vibrations travel, the quieter the sound gets. Right. Time to get back to Sarah. Express -3, 2, 1.
While XP was getting lost, I got on with my end of the investigations. I went over to the building research establishment, where they had special sound testing rooms. I was going to meet a sound scientist called Les. I need to find out about sound.
Well, you've come to the right place, and we can start behind this door. This is one of our special rooms, Sarah.
Wow. So what did they use it for?
Go in and make some noise, and then you'll find out. Well, what did you think of that, Sarah?
Well, I was expecting it to be like more echoey, like the gym in school, but the sound was just like all smothered.
That's because ordinary rooms have hard walls, and when the sound strikes them, it's reflected back into the room. But in this special room, all the walls are covered in these soft foam wedges, and they absorb the sound instead of reflecting it back. So the room's almost completely dead. It's called an anechoic chamber. That means without echo.
All right. So how come you couldn't hear any traffic from the outside getting in?
That's because the walls are very thick and heavy, made of concrete. And they're so heavy, the sound can't penetrate through them.
Oh, great. Well, are there any other rooms we could try out?
Yep, we've got another one that's just the opposite of this.
I've never heard echoes like that before.
That's because the room is built to make it as echoey as possible. All the walls are hard and shiny, so the sound waves bounce around. And we've even put those Perspex panels near the roof, which makes the sound waves bounce around even more than they would with just hard walls.
Well, I have this friend, you see, who's called XP, and he's got these really bad problems to do with noise. So is there anything you could suggest that would help him?
Well, he could put his hands over his ears like that.
Yeah.
Or better still, he could try a pair of hearing protectors like these. These little cups are like building a wall round each ear, so you can lend him these.
Oh, thanks a lot. Okay. Bye.
Oh, Sarah, thank goodness it's you. You're not lost too, are you?
No. What are you doing here?
I brought you back a present from London.
Oh, that was kind of you, XP. Thanks. Here, I've got you something as well.
Alidocious. Just what I've always wanted. Knee pads.
No, XP, they're ear defenders. You put them on your head, and then the vibrations can't get into your ears. If you wear them properly, that is.
Mega Alidocious at last. A good night's sleep. I've got to try them out straight away. Where's the noisiest noise around here?
Well, that's why XP's here. Fast asleep. Oh no, we forgot something. XP, we forgot to ask anybody why you've got 2 ears. XP, it's time to get up now. XP, it's time to wake up. XP, it's time to...
Ah!
Looks good, eh? It's XP's new invention. I'm giving him a hand with it. Don't ask me what it actually does, though. He hasn't got round to explaining that bit yet. But he will. See, it all started when I was having a nice quiet rest.
Sarah!
What?
Sarah!
I thought I'd told you to stop doing that.
Doing what?
Well, just dropping in out of the blue. I mean, I thought I'd explained about privacy and knocking first and all of that, and you promised the next time you'd come, you'd go to the front door and ring the doorbell.
But I did.
Well, I didn't hear anything.
No, because the buzzer didn't work.
What are you going on about?
I pressed the buzzer loads of times, but the bell didn't ring.
Oh no, there must be something wrong with it.
Good.
What do you mean, good?
Well, I was thinking of a new investigation. Something to do with crisps, I thought.
Any old excuse to get more packets, eh, XP?
But now I can do an investigation into why your doorbell isn't working. Wait here. Express minus 321.
You don't need the whole door, XP, just the bell.
Ah. Repeat express. Again?
Can take you next door and have a really good look at it. I'd never bothered to take a close look at the front doorbell before. It was in bits. There was a bit that you pressed, the bit that made a noise, and a battery. They were all joined together by some wire.
Well, the button thingy works all right. And the noise thingy works. Must be this string stuff that's not working. What's it for, anyway? To tie the bell to the door with?
No, it's not string, it's electrical wire. Loads of things have electrical wire. It's for the electricity to travel along.
Shrink factor 5. Well, I've had a close look, and there doesn't seem to be any electricity travelling along it. So, we found our problem.
Yes, we found the problem, but we haven't got an answer. And anyway, you wouldn't be able to see the electricity. It's invisible.
Well, how do you know it's there, then?
I don't know. Just stop asking difficult questions.
Where does electricity come from?
Yeah, you've got it.
Have I? Where? Can't see it.
No, the electricity comes from here. The batteries must be dead.
Wait a minute.
There you go, now ring the buzzer.
That is amazing. How does it happen?
I don't know, but I bet we could find out though. Come on.
Electricity. There we go. Electricity.
Electricity is what we use to work machines like radios, washing machines, and vacuum cleaners. There are two main ways to get electricity.
Pick mains electricity or battery power.
Oh, let's pick the first one.
Okay.
Many things in the home get the electricity they need to work when they are plugged into a socket in the wall. The electricity is made in a power station and is pushed down large cables to people's houses. This electricity is known as mains power. Mains power gives electricity a massive push. This push is so powerful that it can easily kill you. Never experiment or play with mains electricity.
I don't think we should investigate that one, Sarah. It looks dangerous.
Yeah, dead dangerous. Let's try battery power.
A safe way to get electricity is from a battery. Batteries come in all shapes and sizes. From this large car battery to this tiny watch battery. Even the biggest battery hasn't got as much push as mains electricity. But big batteries can still give you a nasty shock. Batteries push electricity round a circuit. If you put something like a bulb in the circuit, the electricity will make it work. You must have a complete circuit to make the bulb light. To turn the bulb off, you could make and break the circuit by pulling out a wire. But a much easier way of controlling the bulb is to use a switch. When the switch is on, the circuit is complete. When the switch is off, it makes a break in the circuit and the electricity stops flowing.
Well, you got enough ideas for an investigation now, XP?
More than enough. What about you?
Oh yeah, same here. I'm going to start some experimenting.
And I'm going to do some investigating.
Well then,
Disconnecting. Investigating electrical circuits. Scan for observations.
Scanning. The switch on this cassette player is switched on. When the circuit is broken, it is switched off. There are circuits in this computer game. The buttons on the front are the switches that control them. This security guard has a circuit in his walkie-talkie. The button he presses is the switch that completes the circuit and makes it work. Warning! He has not seen anyone from another planet before. Suggest you show him you do not mean any harm.
Activate smart specs. What are you on?
Activated. Scanning. This is Greenwich Toy Library. This racetrack has a special switch. When you put the peg in the hole, it completes the circuit and starts the cars. This electric robot has a very large switch. This is so that children with special needs can play with toys that have circuits.
Shrink factor 10. Oh dear. Speed disconnect. Express -321.
I wanted to find out more about which materials let electricity travel through them and which ones didn't. So I got a battery and made a circuit. Okay, let's see if I got this right. Okay, I think that if I touch these two wires together, then it should complete the whole circuit. The electricity will run out of this end of the battery, along the wire, into the buzzer, making it buzz, out of the buzzer again, back into the wire, round back into the other end of the battery. Let's see if it happens. Yes, my circuit works. Okay, now for the experiment. Instead of touching the ends of the wire together, I was going to touch them to the ends of something else. If electricity passed through it, it would complete the circuit and make the buzzer buzz. It did when I used a fork, so I knew that the fork conducted electricity. So, fork does conduct. I tried a rubber band next. I predicted that it wouldn't conduct electricity. I was right. I predicted the same about a wooden ruler. I was right again. Wood didn't conduct electricity. Next, I tried a copper bracelet. I predicted that electricity would pass along it. And it did. Copper did conduct electricity. I tried a 2p coin as well. And that conducted electricity too. Then I got a pencil. It didn't conduct electricity when I tried the wooden part, so I thought I'd test the middle bit of the pencil. This time, it did buzz the buzzer, only not quite as loudly as the others had. Okay, let's just see if I've got this right. The fork, the copper bracelet, the 2p coin and the middle bit of the pencil do conduct, and the rubber band, the wooden ruler and the pencil wood don't conduct. Okay, that's something to show XP when he gets back. Where's he got to?
Activate smart specs. Scan to locate.
Activated. Scanning. You are at the South London Science Centre.
Aha.
This is Paul. He is an electrical model maker.
Hello, I'm from another planet and I'm investigating circuits. I wonder if you can help me.
Yes, I can. I've got some over here. Follow me.
Great. The thing is, I've seen lots of circuits, but I'm still not sure how they work.
Well, that's because quite often XP circuits are hidden inside the casing and you can't see what's going on inside. In this example, we can take the casing off and we can see that we've got some batteries here. Electricity comes out of here, down this wire, through a switch, and when I press the switch, electricity flows through a buzzer, makes a sound, and electricity continues around back into the battery. The circuit always has to go around back into the battery. On this side, we have another circuit. This time it comes out of the wires before, through a switch, but this time the electricity makes a motor spin round, an electric motor. But again, it has to flow through the motor and then back around into the battery. This is another circuit that I've made. This finds out how steady your hand is. What you have to do is you have to move this loop around this bent piece of wire without touching it. And if you do touch it, That completes the circuit and makes the buzzer buzz. Let's just explain how that works. We have some batteries here, and the electricity flows down this wire into the bent piece of wire, and then when you accidentally touch it, the electricity can then flow down along this wire and then back through the buzzer and back into the battery.
Paul took XP to where some children were making a whole load of different circuits. There was one where the switch was a clown's nose, so when you pressed his nose, it made his tie spin round.
So that button is a switch, is it?
Then there was a quiz game with questions down one side and the answers down the other.
Can we have a look underneath, see how it works?
Each question and its answer were on a circuit, and when you matched up the question to the right answer, it completed the circuit, and a buzzer went off and a bulb lit up.
So now we've got to think up some questions and answers that link up. In this one we've got some different kinds of nuts here, but of course they're all mixed up. So let's try and find out what this one here is. We hold the wire onto its paper fastener. And let's work our way down. No, it's none of these. It's a pistachio nut. And each of the others, let's find out what this one is. I reckon that might be a peanut. Yes,
Then there was a circuit built into a birthday card. When you closed the card, it completed the circuit and lit the lights on the front.
There's a red wire, and that's the plus one, and that goes to the top one that is attached to this and will go on the longer wire side.
Okay, so that top one, that's the plus, and that goes to the long legs, right?
Yeah, and this one is
that's the minus.
the minus, and it goes to the other side.
Okay.
And then when you hold it together, then you complete the circuit and lights will light up.
Wow!
XP had a great time and wanted to find out even more.
Thanks a lot, Paul.
My pleasure.
Bye, you two. Disconnecting. Aha! What have we here? There's the wires, there's the battery, and there's the switch that completes the circuit. What else have we here? There are the wires, there's the battery, and there is the switch that completes the circuit. Cool. Same again. There's the wires, there's the battery, but no switch. The coin completes the circuit. Great. There's the wires. There's the battery. Where's the switch? Paul must have left me a banana. That's given me a really useful idea.
So, XP called me over to give him a hand with all the final bits and pieces, and now at last it's finally finished. So, please, will you put me out of my misery? Tell me what this is.
Just a moment, Sarah. You haven't told me what you found out yet. How did your experiment go?
Well, I found out that electricity can travel through some things, but can't travel through others. What did you find out?
I found out that electricity travels through a circuit. So, to light up a bulb, you need a power source and some wires and a switch to control the circuit.
I wonder how many bulbs you could light with one battery. Let's do the experiment.
All right, but first I present Securicrisp.
Securicrisp?
Yes, my battery-powered alarm and security device to guard my prawn-flavoured crisps from burglars.
And how does it work?
It's a simple circuit. The electricity travels from the battery there, through the flashing lights, through the alarm, down here, and on its way back to the battery there, it activates the walloper here.
What's the walloper?
Look, in the middle. If a burglar puts in his hand to try and get my crisps, he has to touch this thing here, which is connected to this switch, which completes the circuit, setting off the lights and the alarm. Then, while he stands there in amazement, the walloper comes down and wallops his fingers. Would you like to see?
I sure would. Now you're not going to get your own fingers walloped, are you, XP?
Of course not.
Carrying all that stuff, XP. I mean, I thought I told you to bring a trolley.
I did. It's with the other metal in my rucksack.
Well, I meant for you to put all the stuff in the trolley and push it, actually.
Why would I want to push my rucksack in a trolley? You are silly sometimes, Sarah. Anyway, look, we're nearly there.
Sometimes I wonder if me and XP are speaking in the same language. Still, with him being from another planet and everything, I suppose I'm lucky we can communicate at all. He says there's something he wants to show me. I really should catch him up and find out what it is. I'll tell you how it all began.
XP had gone to fetch a parcel for me for the recycling project we were doing at school. He took a stroll on the way back, and things didn't quite go as he expected.
Okay, this lot can go here, and this lot can go here. Where have you been, XP? You've been ages.
But it was this box. It made me late.
I've had some excuses in my time.
No, really, while I was walking along it, trying to hang on to things as I went past, I had to keep pulling it off. Maybe it didn't want to come here. Wonder why.
I think I know what's going on, but if I'm right, then there's been a mistake. Open up the parcel.
Oh, all right. What is it?
Well, it's the magnet we ordered, except it's the wrong size. We ordered a much smaller one.
What's it for?
For our school's recycling project. You know, sorting things out so they can be used again. Our group's doing metals, see? And we needed this magnet to help us. See?
That's amazing. You know, there's so much more to Earth than I ever realised.
Yeah, well, we like it here too, XP. That's why we do things like recycling, so that we don't use up more than we need to.
But who makes these magnets for you? Where do they come from? And what makes them work?
One thing at a time, XP. I've got to sort out these cans of things, so why don't you go and look it up on the computer?
No need, Sarah. Activate smart specs. Scan to inform. Audio on. Activate scan to.
Got a problem there with your alien thingamies, XP?
Well, they're not working.
Probably because you're standing too near to the magnet. They can make things go a bit funny sometimes, you know.
I know. I'll go and use the computer. M-A-G... M-A-G... Oh, yeah. N-E-T-S. All about magnets. Making magnets. Electromagnets? Fascinating facts. Let's have all about magnets. We'll activate Scan Do, or access and download.
Magnets are special pieces of material that have an invisible force. This force will pull some metals towards the magnet and will pull other magnets towards it, or push them away, depending on which end of the magnet is pointing at them. Objects that are attracted to magnets are made from things that have particular metals in them, iron, nickel, or cobalt. There are two parts to a magnet, and each one is different from the other. You can see how this is so when you put two magnets together. The two parts that are the same will push away from each other. The two parts that are different will stick to each other. These parts are called the magnet's poles. There are magnets all around us. Things like televisions, stereos, microphones, fridges, and hairdryers all contain magnets.
Deactivate Scan Do. Maybe I should see fascinating facts as well.
The Earth behaves as if it had a giant magnet inside it. The poles of the magnet are close to the very top and bottom of the Earth. A magnet shaped like a needle and free to turn will always point north-south. That's how a compass works. The needle of a compass is magnetic. It is attracted to the poles of the Earth. One of the most powerful magnets in everyday use is the kind you see in a car breaker's yard. They can pick up heavy loads of metal and move them easily.
Cool. Express -321. Express -321.
I took all my cans down to the community centre to sort out. I was supposed to sort the steel cans from the aluminium ones because they were going to different recycling places. But I wasn't sure how the magnet was going to do it.
Now, let's see if I'm right. I think that magnets attract metal. Now, my project book said that this magnet should be able to help me sort out all these cans. But they're all metal. So then how is the magnet going to be able to tell which is which? Doesn't sound right to me. Oh well, let's try it anyway. Try this one. Yep, so you can go in here. So can you. Wow, they don't all stick. I wonder why. Maybe I could plan an experiment to find out. Yeah, I could do all this lot afterwards. Now, let me see.
Oh no, not again!
XP had found a place where they had some really big magnets and had gone over to take a look.
Scan to locate.
Activated. Scanning. You are at Amptill Metal Company. This is Michael. He is a metal recycler.
Hi, I'm XP. I'm from another planet.
I gather you've got some really big magnets
We
here.
certainly have. Perhaps you'd like to have a look around.
Yeah, great.
These grabbers are sorting out all the scrap metal. This metal car body is going into a machine called a fragmentizer. The fragmentizer chops the car into tiny pieces. The pieces of metal travel along a conveyor belt. The conveyor belt takes them to the shed next door, where there is a special magnet called an electromagnet. The magnet sorts the magnetic metal from the non-magnetic metal and separates them onto two different conveyor belts.
God, that is extraordinary. Have you got any more electromagnets?
We have. If you'd like to pop and see Mick over there on the magnet crane, I'm sure he'll be pleased to show you.
Thanks very much, Michael. Thanks very much. Hello, Mick.
Hello!
How does it do that?
It's electromagnet. I can switch electricity on, which makes it magnetic, and I can switch it off again. Unlike a normal magnet, which will only pick things up, you can switch this one on and off. You can switch it on to pick up and off to put things down.
Can you do that again?
Yeah.
SmartSpecs, scan to confirm.
Activated. Confirming. Electromagnets are magnets you can turn on and off. When Mick presses the switch, the electric current makes the electromagnet work. When he switches the current off, the electromagnet stops being magnetic.
Meanwhile, I'd got my experiment all planned. It was to help me find out what stuck to magnets and what didn't.
Okay, I think these things won't stick, And these things will stick. Let's see if I'm right.
The wooden spoon wasn't magnetic. Nor was the china saucer, or the cardboard tube, or the rubber band, or the ball of string. So, I recorded the results of my test, and then tried the ones I thought would be magnetic. But the gold locket wasn't. And neither was the copper bracelet. The steel can was.
You can stay here.
And so was the iron horseshoe. But the aluminium can wasn't magnetic.
Over here.
So, I recorded my results and wondered just what they meant. Just then, XP called me up.
XP connecting Sarah. XP connecting Sarah.
Connected. Just who I wanted to see. I'm stuck.
Well, you should be more careful with the magnet.
No, I'm not stuck to the magnet. I'm stuck. You know, when you can't answer a question.
What is it?
Well, what's the connection between iron and steel?
Why do you want to know?
Because whatever the connection is has got something to do with magnetism. I know. You could use your smart specs to help. Scan over these things and see what it says.
Mm-hmm. Activate smart specs. Audio on. Scan to identify.
Activated. Scanning iron and steel.
Question, are they connected in some way?
Answer. Steel is made from iron. It is made by adding carbon and sometimes other metals to iron.
Sarah, they've both got iron in them.
Ah, brilliant. That explains it then. Oh, flip. I haven't sorted through all these cans. Forgot all about them. They're going to be coming to collect them soon. You couldn't come down and give me a hand, could you?
I've got a much better idea. I'll come over and collect everything and show you a quicker way of doing it.
So, that's why we're here. It's got something to do with the electromagnet that XP saw earlier. Come on then, where is it?
They've let me borrow the magnet from the crane. All I have to do is activate it with the scan-do and we'll have your stuff sorted in no time.
Oh, wow, brilliant idea. How does it work?
It works only when you pass electricity through it.
So how do they make magnets that stay magnetic then?
I don't know. Why don't you find out later? But first, tell me, what did you discover?
Well, I found out that not all metals are magnetic.
But some are. Let's sort yours out. All I have to do is access the scan-do and then activate the electromagnet. Here goes, switch on now.
Don't worry, sir. No problem. I'll just go and get it back.
Oh, look out, XP! There's a saying for that on Earth, XP. It's called dropping a clanger.
There was a time, before there were cars, when the camel was called the ship of the desert, the best way of carrying people and packages across sandy and rocky countryside. What helps make the camel ideal in dry climates is that it needs little water to survive. The hump on its back provides energy when food is hard to find. But given the right diet, camels don't need to drink much H2O, which is ironic, since the new generation of motor vehicles might well depend on it. For water could provide emission-free fuel for the future. The image projected by TV advertising is that driving is an experience to enjoy.
You don't need to see everything to know it's there. No keys, no gear stick, no handbrake. Because BMW believes innovation shouldn't mean complication.
While sitting behind the wheel may be luxurious, comfortable, pleasurable, from outside, the picture is different. Cars use petrol or diesel. Petrol and diesel come from oil. Using oil leads to exhaust fumes, and exhaust fumes are said to be contributing to climate change. And what's more, oil is a non-renewable energy source. Once it's used up, there won't be any more, at least for a few million years. Now, you're probably getting tired of watching television programs full of doom and gloom. It seems that adults spend all their time warning about the end of the world as they know it. In fact, they've been doing it for at least 100 years, and probably longer. And yet we're all still here. Isn't it true that for every problem, something always comes up? Over the years, various alternatives to non-renewable energy sources have been tested, but oil still provides the main fuel for road transport. There have been prototype cars using renewable energy sources. Solar-powered cars like this, however, haven't proved to be practical. As for wind power, it seems to have got little further than the beach. And anyway, what happens when the wind drops? Which leaves us with water power. And the record here is good, since water has already been used successfully for transport. Old railway engines were powered by steam from water that was boiled on board. Trouble is, coal was needed to boil the water, and coal is non-renewable. But water could still provide the answer, because the approach now being taken by researchers uses water differently.